Hi folks, and welcome back. Today is Lesson 10, Configuring Network and Wireless Settings. This is the latest installment of the Microsoft 7687 exam covering Windows 8.1. And today we're going to be looking at an exam objective 3.2, and predominantly we're going to be talking about wireless 802.11 networks. One of the things we're going to talk about is the security concerns surrounding 802.11 networks, as well as some ways that we can mitigate those concerns. As part of that mitigation method, we're going to look at two encryption protocols, the two predominant encryption protocols in wireless networks today, WEP and WPA. And then as we start rounding out the conversation, we're going to look at some other ways to configure settings to connect to a network, i.e. Ethernet. And we're going to also look at a new feature, the LocationAware Printing feature. So let's go ahead and get started. Wireless networks, of course, are the predominant method of choice for any mobile Windows device that's trying to connect either to the internet or to a LAN of some sort. It uses radio waves to connect to an access point or through ad hoc into some other computer using a wireless adapter. Wireless networks do use protocols like any other communication method that are established by the IEEE, the Institute of Electrical and Electronic Engineers. They are tasked with coming up with these new ways to communicate and then disseminating these standards into the production environment. Now, there are literally dozens of standards out there covering wireless communication. For our purpose today and for wireless networks, you need to be aware of 5. That is A, B, G, N, and there's a new one out there called AC. In the last 6 months, we've seen a significant number of AX standards being developed. AC was released in December 2013. AC is going to be out shortly as far as on new routers. It has a 1.73 gigabit per second data range, significantly higher than its N counterpart, and it's also significantly better as far as the indoor range is concerned. N has an indoor range of approximately 250 meters, and I'm told by the experts that AC can surpass that by 30% or more. So if you're looking to improve your wireless network or extend your wireless network any further, look for a wireless router coming out in the near future with the AC standard built into it. Alright, so connecting to a wireless network could never be easier, and Windows 8.1 has certainly made it as easy as it can be. If it's broadcasting an SSID, then of course it can be picked up automatically, and it's made available to connect through the Windows interface as long as your wireless adapter is enabled. Now, non-broadcasting SSIDs may need to be manually configured through the Network and Sharing Center. Now, that center is located in the control panel off of the desktop. And the Network and Sharing Center provides a central location for pretty much all of your network configuration needs. That will include things like changing the adapter settings, managing wireless networks, and of course configuring any of the network sharing settings on the computer. Here's a screen from the Manage Wireless Networks window out of the Control Panel's Network and Sharing Center. And as you can see, what you have here is a list of all of the networks we've connected to in the past. And when we have connected to those networks, we develop what is called a profile for that network. And that profile is saved as a file on the system and stored for the convenience of connectivity when we want to connect to it later on. In this screen, you can see some of the wireless networks I've used in the past. And you can see, based on the breakdown here, the type of encryption it uses, the type of adapters it supports, and how it's set up in our Windows environment, whether it should automatically connect or connect through a manual process. This is the screen where you would go in and add. If you don't have broadcasting SSID on your network, then you would want to go in and add it manually from here. Now on this screen, I threw this screen in to point out a couple of things, at least as far as security goes. This is a Sniffer screen that was a snapshot taken from a recent job I did. I was contracted by owner of a wireless network to go in and ascertain where the network was failing on the property and then effect repairs or extensions in some way. And as you can see from this wireless sniffing utility, I get some pretty good information. I find out, for instance, the projected range of the wireless network, as well as if you look around the edges of the screen, you will see that there are literally dozens of networks popping up. These are networks that the sniffer finds while the session is active. And if I were to click on any one of these links that it creates, I will identify that network, and I will also get some good information about that network. For instance, it will tell me not only the SSID, but whether or not it's encrypted and what type of encryption, if it is encrypted, it uses. In addition to that, if you'll notice, the icons are different. There are some icons representing Linksys routers and some representing Netgear routers and so on and so forth. So it also gives me an idea of what type of device is being used to broadcast that SSID. Now, this information can be useful both for me as a IT support person to help figure out what's going on with the networks, but it's also a useful tool for people who are not so friendly, people who are out there to do nefarious things. People who go out and pick this information up, we say that they're war driving. That's the term that we use. They go out and they locate these networks, identify these networks so that we can come back to them in the future, maybe figure out a way to crack into the network and do whatever nefarious activity that they're doing. Wireless networks pose some interesting security concerns. War drivers use tools like this so that they can go and connect to a network and can be hundreds of feet away. The owner might not even be aware at all that there's anyone connecting to that network because they're off the property. As you can see, the way the network here that I'm scanning is broadcasting, it actually broadcasts off the property, and there's no way the owner is going to be able to ascertain if someone 2 properties away is actually connecting to their network or not. So wireless networks pose some interesting security concerns. Some of those concerns are listed here on this screen. Eavesdropping, for instance. Eavesdropping is just what I described. When someone is literally 100 feet away from your property, they have figured out a way to crack into the network, and they can sit and listen to the data being generated. They can then in turn use this data later on to, say, access your bank account, you get credit on your behalf, or break into a server that you're connecting to. Masquerading is the term that we use for anyone who breaks into the network pretending to be a legitimate user on the network. They pretend to be a device that is authenticated to that network. We call that masquerading. Of course, there's also people out there who use the ability to connect to your network to devise some sort of attack against that network. There are a wide range of attacks that we can perform to wireless clients. We can break into their systems, install keyloggers. We can flood the network with meaningless data and perform what we call a denial of service attack, which is where we actually bring the network down by flooding it with so much data that the wireless access points can't process it. And of course, then last but not least, there's the whole concept of data tampering, where we can actually go in and modify the data that's being generated by a user to either break into a remote server, say, we could end up taking over that session from the user, or modifying the data that they're generating to give them a different result back based on the information they've sent out. We can alter it, and then that information is altered, so the information they get back is going to be altered in some way, shape, or form. We call that data tampering. So how do we deal with these security concerns? Well, one of the first things you should do if you're running a wireless network is set up encryption. And there are 2 types of encryption methods out there. There's WEP, the wireless encryption protocol. We see that rarely used these days, partly because its encryption method is significantly weaker to its counterpart, which is WPA. Now, there's some things you should know about WEP. For instance, it does utilize the 2 lowest levels of the OSI model. It uses a shared key. That means someone's got to give you a key in order to connect to it, or they've got to enter it themselves so that you can connect to the network. And there are 2 types of standards that we can connect using WEP. There's the open system standard and the shared key method. We as IT support people prefer the open system standard as the method of choice if you're going to be using a WEP protocol. And you're like, well, why would you use it? You just told me that it's a weaker protocol. That's true, but there are a lot of older devices out there, not necessarily computers, but there are other devices out there that need to connect wirelessly, and WEP is the only game in town for them still. And so because of that, you may still see a WEP enabled network somewhere. WEP encryption can be broken. It can be broken actually in a matter of minutes. I remember a story someone told me about the sheriff's department, not our sheriff's department, but a sheriff's department, where they were using WEP encryption to encrypt data to and from the laptops in their automobiles. And someone came on site and decrypted their security key in like 10 minutes or so. So it was a wake-up call for that department to go ahead and figure out a way to move on to WPA encryption. But anyways, the open system method, because we don't need to send the secret key as many times to connect and maintain that connection with open system, we're not giving out the key as many times. That's not as easy for whoever's intercepting the data to pick up on the key, and that will help reduce the risk of cracking. If you are going to use WEP encryption for any reason, there's a reason why that routers using WEP will allow you to store up to 4 keys at once, and that is because they recommend that the key be changed very regularly. And that's one of the biggest problems with WEP users, and one of the reasons why it makes it so unsecure is that they forget, they get lazy, and they don't swap out their shared keys as regularly as they should. Alright, so the counterpart, as I said before, is WPA, or Wi-Fi protected access. This is the predominant encryption method of choice in this day and age for wireless networks. It was created by the Wi-Fi Alliance to help address some of the concerns in the WEP protocol. Now, when WPA first came out, it used a standard called Temporal Key Integrity Protocol, TKIP. It scrambles the keys using RC4 encryption. It's a 128 key hashing algorithm, and by adding an integrity checking feature, it will ensure that those keys haven't been tampered with. The latest version that came out with WPA2 is the Advanced Encryption System, or AES method. It uses a counter cipher mode algorithm with CCNP. It's WPA Personal. There are 2 ways we can use WPA. There's WPA Personal, or as some people know it as WPA-PSK, with a pre-shared key mode. It's used in conjunction with a passphrase, very similar to WEP. You have to enter a passphrase of 3 to 63 characters, and it is combined with the SSID to frequently regenerate new encryption keys or new session keys to maintain the security of the wireless connection. If I wanted to take that a step further, particularly if I'm in an organization, I can set up a Radius server to help facilitate security with my WPA encryption. We would then call that a WPA Enterprise account, and it has to have a Radius server for it to operate. And the advantages to the Radius server is that as an administrator, I can get some central administration, I can do auditing, I can have some significantly advanced logging capabilities built into that server, which can help facilitate some additional security in my WPA encrypted environment. Alright, so some other ways that we can protect the wireless networks besides encrypting them. Well, first and foremost, we need to enable and configure the wireless router firewall. Most routers today, wireless routers, do come with some sort of firewall. And firewalls are designed to protect computers from harmful intrusions. And they do this by monitoring the ports. A port is not what you think, is not some sort of a physical connection that you see on the device, but it's actually a software connection point where data from software is sent out over the internet. We call that ports, and there are roughly 65,000 ports available on a typical Windows device. And the firewall is tasked with monitoring those ports, applying certain rules to protect data going through those ports, and in some cases, if you have a stateful firewall, actually looking at the state of those ports. Is the port already open? Is it closed? And if it's closed, is someone trying to get into an already open port? And if it finds out or finds a data packet that does not meet, does not make sense with regards to that current port state, it will drop it. Same thing's true for any packet of data that does not meet the rules that you've set up on the firewall. It will just drop the packet, thereby helping to protect the network. So being able to enable and properly configure the wireless router firewall is a significant way that we can improve security on our wireless network. We also need to be aware of the simple things like changing the default passwords. Right? All these routers come with preset passwords for administering the device settings, and that makes it very convenient when you want to set up the wireless router for the first time. Well, you have to have a way to get into the router, and most of these routers have a web interface, and you type in the default password and you can get into the router. The problem with that is that people who are out there doing war driving, they know these default passwords, and if you have not changed the password, you're giving, even though you've got the wireless network encrypted, and even though you've got the firewall up, they can ascertain the gateway interface and simply break into the wireless router, change the settings that they want to change so they can gain easy access to the wireless network. You're totally unaware of this unless they accidentally take you or kick you off the network in the process. So you need to be sure, one of the first things you need to be aware of is you need to change the wireless router password to something that you can remember but is totally different from the default password. Write it down somewhere and keep it handy. Likewise, we need to change the default name of the network SSID, the identification that we use to broadcast our network. It's just good practice. It makes it easier. If you went back and looked at my Sniffer, you will notice that there are a couple LinkSys SSIDs being broadcast where people didn't change the network SSID. This is just another way that we can further help identify our network. By the way, if you're going to be, when you change your network SSID, don't change it into your wife's name or your kid's name or your street address or anything that can readily identify you. That just makes it easier for people to figure out where they're connecting to, and they can use things that gives them an aid as far as how to break into your network. They'll start thinking about passwords like, okay, well, his name is Jim and his password could be his dog's name or whatever. So you want to change the SSID, but you don't want to make it identifiable particularly to you or to your location. Alright, you also want to turn off SSID broadcasting. And broadcasting, of course, is very convenient. It makes it really easy to connect your devices. And it's useful if I'm running a restaurant or if I'm running, I'm in a hospital, running a hospital. I want guests to be able to connect to my network, and I don't want to bog down my IT support team with having to answer a dozen questions about what the SSID is for that network. I will turn on broadcasting. But for the typical homeowner, broadcasting your SSID is just broadcasting out there to people that, hey, try to connect to me, try to connect to me. So just turn off SSID broadcasting unless you have some specific reason why you want that convenience of broadcasting the SSID. Using the MAC address filter is another way that we can further improve our wireless security. MAC address, of course, every device that connects to a network, every adapter has a MAC address, a physical address. And we can find that address by going into the command prompt and typing ipconfig /all. I can actually get not only my IP addresses, but my gateway addresses and also my MAC address, my physical address for all of my adapters. You would then look for the MAC address for your wireless adapter, since you're using the wireless network MAC address filter. And you would go into your wireless router, enable MAC address filtering, and then add the MAC addresses for all the devices you want to connect to the network. Some of these filters actually do it the other way around, where you can actually say, I want to connect everything except the following MAC addresses. This is particularly useful if you've got identified certain MAC addresses that are problems. You can do the same thing with IP addresses as well. But the MAC address filter also helps eliminate or help further reduce the security footprint that your network has. As far as prioritizing networks goes, when you're in a multi-use environment, Windows 8.1 will determine the connection priority automatically, and that's going to be based on the type of network you're connected to. Windows 7 did this as well. Wireless will always be superseded over wired. So that means that if I have a wired connection and I have a wireless connection in that environment and I ask to connect to the network, the wired option will always take precedence over the wireless. Now there are instances where maybe I want to connect to my wireless network, and you're going, well, why is that? The wired network should be much faster, and you're correct. So why should I connect to a wireless network? Well, it depends on your environment. I've been in an environment where we had a wired network and a wireless network, and the wireless network was actually connected to a different type of network where we had different data available to us, and the wired network was connected to another segregated network with additional types of data. Or maybe the wired network is showing some sort of latency at any given moment. Maybe it is running much slower. There's some sort of bandwidth issue going on. And so you may say, well, this is not working, I'll just switch to the wireless network. So there are two things you could do. You could either unplug the Ethernet cable out of the back of your laptop. That will certainly make it default to the wireless network. Or I can go in and temporarily disable the Ethernet adapter via the Network and Sharing Center in order to connect to that wireless network. Of course, if I do that, then you have to remember to re-enable that network adapter after I'm done and I want to reconnect to the wired network. Alright, so as far as wireless profiles go, well, if you looked on my Manage Wireless Network screen earlier, you saw that there were dozens of profiles up there. And because of that, we need to have a way to manage those profiles, and we also need to have a way to remove unwanted profiles for networks I don't plan to connect to in the near future. So, how do we do this? Well, first of all, you need to be aware of the fact that wireless configuration profiles are basically files. They're stored as files for convenience sake, so that the next time I want to connect to the network, I don't have to re-enter all the information. It doesn't have to re-pull all that information together. So it stores it as files. Now, profiles can either be viewed through the GUI interface, the Managed Wireless Network Connection that you saw earlier, or I can do it through the command prompt. And the command that I would use for that is netsh. The command you see down here at the bottom of the screen is the command I would use to show those profiles, and indeed when I use that command in my computer, these are the profiles that come up for me. As you can see here, I have, 2, 4, 6, 8, 10, 12, 13 profiles. You also want to point out on here, you see those two Linksys profiles there where, as I said before, somebody naughty didn't change the SSIDs for their wireless network. So I have no idea whatsoever who those networks belong to. So I want to remove some of those wireless profiles. I don't need them anymore. So I'm going to have to remove them. And I can do that through the GUI as well. I can right click on the profile in the Managed Network Profile Center and select Remove Network. I can also do it from the command line. And once again, I'll use the netsh command to do that with. And when I do, I end up with a command that looks like this: netsh wlan delete profile, and of course the name of the profile that we're deleting in this instance is George, good old George. Don't need to connect to George anymore, so I deleted that profile off of my system. I want to take a brief moment to show you and talk a little bit about managing your Ethernet connection. So what we've done here is we've gone in through the control panel into the Network and Sharing Center, into the network connection screen, and I've actually gone in here and chosen in Network and Sharing Center to configure my adapters. And what I have here on the screen, in the screen on the back side where you see the 4 separate adapters, I have a local area connection, I have a wireless connection below it, and then to your right you'll notice I have 2 VMware connections. I run VMware on my Windows box. I use it to demonstrate products. I use it to test malware. I use my VMware for a whole host of things, to test patches before I deploy them to Windows machines. And in order for VMware to work, and since it's considered a separate system on your machine, it will actually create virtual adapters on the machine. And that is what you're seeing here, is the adapters associated with the VMware product. Now, every type of protocol that you're going to use to connect to something as far as typical Ethernet or wireless connectivity will have to have a separate adapter generated for it. And so that's what you're seeing here in the screen. Now on the right hand side of the screen, I simply right clicked on one of these and chose the properties option at the bottom. And this is the screen that you would use to go in and manage those IPv4 and IPv6 connections. Now we've talked about manual configuration of these connections in an earlier lecture, so I'm not going to go in and demonstrate that again. But just wanted to point out that we do this through the Network and Sharing Center. Alright, network adapter modes. Back to wireless again. I do want to talk about two things about network adapter modes. There are two types of modes that we can set up for our wireless adapters. We can turn it on to ad hoc mode while we're changing the adapter settings. That wireless network adapter configured to ad hoc mode is configured to connect to other devices. We're avoiding the WAPs, the wireless access points, and we are connecting to other systems who are also using wireless network adapters. This is one method of communication that we can use wirelessly over the airwaves, is the ad hoc mode. The other way, and the more common method of communication, is through infrastructure mode. This is the wireless network adapter being configured to connect to wireless access points, which is generally what you're going to be using when you're connecting to your home wireless network, or when you go into the office, or when you go into a hospital or a restaurant. You're going to be connecting through infrastructure mode to a wireless access point. Last but not least, we're just about done with the lecture today. I do want to mention location-aware printing. Location-aware printing is actually kind of neat, particularly for those of us that are going to be connecting to multiple networks and we need to print in those networks. So first of all, I want to point out that location-aware printing is only available in Windows 8.1 Pro and Enterprise laptops or any device that runs on a battery. So if it identifies that Windows environment as a mobile environment, then the location-aware printing is going to be a feature that's available to you. It is, as I said, new for 8.1. It does allow us the automatic configuration of a default printer based on my current network connection. So if I connect to one network and I set up a default printer on that network, and I connect to another network and I set up a default printer on that network, from that point forward, as I switch from one network to the other, provided that I have the location-aware service and the network list service running on my system, I will be able to automatically switch between those two default printers. And it will do it without I won't have to do anything. It just knows to print to this printer or the other printer. We enable this feature, so you have to have those two services running, I mentioned before, and then you have to go in through the devices and printers and manage default printers, and then choose to enable the location-aware printing. It's just a little checkbox that you check. Alright, so let's summarize. Wireless networks are based on the 802.11 IEEE protocols. There are 5 protocols that you should be aware of if you're going to be doing anything with wireless networks. ABG, N predominantly used today's environment, and the upcoming AC. Each generation is providing us with better data transfer rates and of course better ranges to connect. Wireless networks are particularly vulnerable to a wide list of attacks. These attacks are designed to infiltrate and or disrupt the network. I can help ensure my Wi-Fi connection is ensured through encrypting that network. I can turn on my firewalls. I can use MAC filtering. And of course I need to also properly configure my wireless router not to use those default passwords. The wireless equivalent privacy, or WP, and the Wi-Fi protected access, WPA or WPA2, are the two main security profiles that we use in wireless LAN devices to encrypt the data traveling through those devices. And of course Wi-Fi protected access is the predominant and the most favored flavor of choice when it comes to encryption, because it does address some of the weaknesses in the WPA protocol. It does currently employ 2 encryption options: the Temporal Key Integrity Protocol, TKIP, originally developed with WPA, and then of course the Advanced Encryption System, AES, which came out in the latest version, WPA2. Just a reminder that a wireless network, as long as it's broadcasting its SSID and it's in range of your Windows 8.1 computer and your wireless adapter is enabled, it's going to appear in the list of available networks. All you have to do is simply then click on the Network Center and then choose the appropriate, add the appropriate security key in order to connect if it's encrypted. If it's not broadcasting, you're going to have to configure all the settings manually through the Manage Wireless Networks interface through the Network and Sharing Center. A wireless profile is really a file. It contains the wireless SSID, all the security configuration information, and of course the appropriate security keys for the convenience of allowing you to connect to that the next time you come in more seamlessly. Okay. However, if you are not wanting to connect to that particular network, you want to connect to another one, we do have the Forget This Network option. If you are currently in range, or if you're not in range and you want to delete the profile permanently, you can do that simply by going into the command line and typing out the command for deleting the profile name altogether, or simply using the GUI interface and deleting it by right-clicking on the profile and choosing Remove This Profile. There are two modes that we use in wireless. We use the ad hoc mode to configure a wireless network adapter to bypass those wireless access points and connect directly to other wireless systems. And of course the more traditional infrastructure mode used when I want to connect simply to a wireless adapter using a WPA environment. Also, last but not least, a new feature, the LocationAware Printing, allows me to automatically connect to my default printer depending on what network I've connected to, based upon the fact that I'm using a mobile device to do that with. So that's all I've got for today's lesson. I will talk to you next time when we talk about the next lesson, Lesson 11. Have a great day.